Welcome to This Explainer. Let's just jump right in, shall we? Today, we are looking under the hood of artificial intelligence. When you hear about some massive breakthrough in machine learning, it is so easy to just focus on the magic of the final output. But, as we're going to see today, building an AI model follows a pipeline that is actually remarkably similar to cooking a really complex dish. You start with raw ingredients, you follow a rigorous method, and you produce a finished dish that you can serve over and over again. So, let's step inside the machine and explore the data, training, and models pipeline.
Here is what we've got on the menu for today's explainer. We're starting with the recipe for AI, then we'll move into prepping the raw ingredients, choosing the right features, cooking and tasting, and finally, we are going to expose something called the perfect score trap.
All right, Section 1, the recipe for AI, moving from raw materials to a finished dish. Pretty much every machine learning system you interact with is built through a highly structured pipeline. It travels from completely unrefined material all the way to a predictive engine. And you can see the 4 distinct stages right here: raw data, cleaning, training, and the finished model. This sequence, it's absolute. You literally cannot skip straight to a finished model. The system has to journey through preparation and training before it can actually do anything functional. It's not magic, it's just a process. Okay, moving on to Section 2. Prepping the raw ingredients. This is all about data collection and cleaning.
So before any actual learning can even start, you have to gather and clean your data. Think about it. You wouldn't just toss a whole unwashed, unpeeled onion right into a frying pan, would you? Of course not. And you can't feed raw data into an algorithm either. Just look at this real estate data table. Row 1 looks great, perfectly normal. But row 2, the square footage mixes letters and numbers, and the word 2 is spelled out for bedrooms. Then in row 3, the price is just missing entirely. Real-world data is messy. It's chaotic. So our very first job is standardizing all of this and filling in the gaps so our ingredients are fully prepped for the pan.
Which brings us to Section 3, choosing the right features, or in other words, identifying the ingredients that actually matter.
Just because you have a kitchen full of perfectly clean ingredients doesn't mean you should just throw every single one of them into the pot. You need to isolate the specific variables that actually drive the outcome you want. Formally speaking, a feature is just a specific piece of information used as an input for a prediction. And honestly, picking the right features is often way more vital than the algorithm itself. A mediocre algorithm that has the exact right features is going to completely outperform a brilliant algorithm that's being fed irrelevant data. The features are the literal foundation of the model's understanding. Let's say we want to predict house prices. What are the useful features? You can see the key variables right here: size in square feet, number of bedrooms, location, and the age of the building. A real estate platform will train its model on thousands of past sales using these exact traits to figure out market relationships. And once the model learns this, it can actually predict a fair market price for a brand new address. But think about it. If we used irrelevant features like, the color of the mailbox or the homeowner's favorite movie, the predictions would be completely useless. Garbage in, garbage out.
All right, let's jump into Section 4, cooking and tasting, which represents training and testing the model.
So we have our clean data, we've got our crucial features. Now, the algorithm finally turns on the stove. Training relies on repeated, small adjustments to minimize the gap between predictions and reality. And I really want to emphasize that word, repeated. This isn't just one instant calculation. It's a gradual, iterative process. The algorithm looks at thousands of examples, it makes a guess, calculates its error margin, and then adjusts its internal weights. It slowly minimizes that gap, getting a tiny bit closer to reality with every single adjustment.
But wait, before we serve this dish to anyone, we have to taste it. Notice the distinction here between the training set and the test set. The training set is what actually teaches the model. The test set, though, is entirely new data used to check how well the model generalizes to situations it has never seen before. It makes sense, right? You wouldn't trust a chef who never tastes their own food. Testing a model on houses it hasn't seen before ensures that our final product is actually reliable in the real world.
Finally, Section 5, the perfect score trap. We are about to shatter a major AI myth. When you test your model, you probably think you know exactly what kind of score you want to see. Consider this super common myth. The more accurate a model is on its training data, the better it is. I mean, it seems totally logical, right? Wouldn't a 100% score on your training data be the absolute ultimate goal? It sounds like you just built the perfect model. Well, actually, scratch that. In machine learning, a perfect score is a massive red flag.
The twist here all comes down to something called overfitting. Overfitting happens when a model just memorizes the training data instead of actually learning the general patterns. And that means it performs terribly on anything new. If a model scores 100% on its training data but completely fails on the test set, it hasn't learned a thing. It literally just memorized the answers. It's exactly like a student who memorizes an old exam word for word. Sure, they're going to ace that specific test, but they'll completely bomb a new test that covers the same underlying concepts. Our goal is to learn the general relationship, not just memorize a list of specific houses.
Which leaves us with this final, really vital thought to ponder. Why is 100% accuracy on training data a red flag? Well, because the true goal of the machine learning pipeline isn't perfect memorization at all. It's true generalization. Keep questioning the data, keep looking for those real patterns, and I will see you in the next explainer.